So we have this integral here, and again, we know that we can write our integrand into this form. Now, what's another way of finding the values of this a, b, and c? So a faster way to find these values is to use what we call cover-up technique in finding the values of a and this c here. So let's find the values of a and c by cover-up technique. So our a is just equal to the value of 7x squared minus 9x minus 4 all over, we covered the 2x plus 1, so we don't have that in the denominator. So the remaining factor in the denominator is x minus 1 quantity squared. And we plug in a value that will make this 2x plus 1 equal 0. And that is x equal to negative 1/2. So plug in x equals negative 1/2. And we'll get here 7 times the square of negative 1/2, so that is 1/4. And then minus 9 times negative 1/2, so that is plus 9/2. And then minus 4 all over negative 1/2 minus 1 quantity squared, so that is negative 3/2 quantity squared, so that is 9/4. And we can simplify this complex fraction by multiplying the numerator and denominator by 4, and we'll get here 7 plus 18 minus 16 all over 9. And this is equal to 9/9, which is equal to 1. And to find the value of c here, so we cover this denominator of c, which is x minus 1 quantity squared. So we have to evaluate 7x squared minus 9x minus 4 all over 2x plus 1. When x is equal to 1, it's the value of x that will make the denominator of c 0. So that is x equals 1. So this will give us 7 minus 9 minus 4 all over 2 plus 1, which is equal to 3. So this is equal to 7 minus 13, so that is negative 6 over 3, which is equal to negative 2. Now, to find b here, so note that we cannot use cover-up technique, because when we cover x minus 1 in our rational function, there will still be a factor, x minus 1, left in the denominator. So that will make the denominator 0 when we plug in x equals 1. So to find the value of b, we just plug in any value of x that is not equal to negative 1/2 and positive 1. And the best choice for x here is x equals 0. So when x equals 0, so this left-hand side here is just equal to negative 4 over 1 times negative 1 squared. So that is equal to 1. Equal to, you have there a over 1, so that is a. And then plus b over negative 1, so that is minus b. And then plus c over negative 1 quantity squared, so that is plus c. But we know already the values of a and c, so this is just equal to 1 minus b minus 2 equal to negative 4, and this will give us b equal to negative 1 plus 4, which is equal to positive 3. Therefore, we can already write our integral as integral of a over 2x plus 1, so that is 1 over 2x plus 1, and then plus b, which is equal to 3 over x minus 1, and then plus c, which is negative 2, so we have here negative 2, and then over x minus 1 quantity squared, and then dx. Now, let us evaluate this integral. This is equal to integral of 1 over 2x plus 1, and then times 2 dx, and then times 1/2. And why did I write it in this form? So that we can easily integrate it, because it is already in the form 1 over u, and then this will be our du. Now we know already an antiderivative of this fraction here, and it's equal to 3 ln of absolute value of x minus 1. And then minus, we have here 2 integral of, we can write that one as x minus 1 raised to negative 2 dx, where we can already apply our power rule. This is just in the form integral of u raised to negative 2 du, where u is equal to x minus 1. So therefore, this is equal to 1/2 integral of 1 over u du. So that is 1/2 ln of absolute value of u. So that is 2x plus 1. And then plus 3 ln of absolute value of x minus 1. And then minus 2, add 1 to the power. So this is raised to negative 1 divided by that new power, which is negative 1. And then don't forget the arbitrary constant c. And we can simplify our answer by writing this fraction here as plus 2 over x minus 1.